All right, it is on polynomials and polynomial functions. Poly means many, and so the word polynomial just means that we are doing something with more than one term in it. So we are dealing with expressions. In this case, if they don't have an equal sign, they're called an expression. We're dealing with expressions that have multiple terms. Okay. Some of them are polynomials, some of them are functions, some of them are not functions. I mean, sorry, all of them are polynomials, some of them are functions, some of them are not functions. Let me give you an example of a polynomial. If you had 6x squared minus 4x plus 9, that is a polynomial. It is also called a trinomial. Tri means 3, right? Poly just means many in this case. So you have trinomial means you have 3 terms. First term, second term, third term. Polynomial just means you have many terms, more than one. If you had one term, it would be called a monomial. A monomial is one term. A binomial is 2 terms, and then a trinomial is 3 terms. So these and anything bigger than that is also called a polynomial. So it's just some new vocabulary. So in this polynomial that I made up, 6x squared minus 4x plus 9. All right, let's talk about what a term is. A term is a number or a product of a number and variables raised to powers. Remember that variables are just letters. We use letters when we don't know what the number is, right? So a term could be a number, or product, remember, means multiply, a product of a number and variables. Here, this is a product. This is the product of 4 and x. This is just the number 9, and this is the product of 6 and x squared. So the variable in this case is raised to the second power. So here, my variable is raised to the power of 2. In 6x squared minus 4x plus 9, coefficients are just the numbers, okay? So you have the term 6x squared, or sorry, let's explain first. All right, so we said a term, let me just make clear what the terms are. The terms are 6x squared, negative 4x, and 9 are my terms here. Again, you don't have to write this down if you know it. The numerical factor of a term is called the coefficient. So the coefficient of 6x squared is the number 6. The coefficient of negative 4x is negative 4. So in this case, 6 and negative 4 are coefficients. Or you could say 6 is the coefficient of 6x squared. The constant is the term that has no variables. If it's only a number, it's called the constant. So 9 is the constant. Six and negative 4 are coefficients. The difference is they have variables. the numerical factor of a term that also includes variables. If it has no variables, you call it a constant. And if you think about it, a constant never, if you're constant, you never change, right? So the rest of my expression, 6x squared minus 4x plus 9, if I put in 1 for x, this amount changes, this amount changes, the 9 doesn't change. If I put in 0 for x, this changes, this doesn't change. So the constant doesn't change because there's no variable that you can replace with a number, okay? So the polynomial is all the terms involving variables raised to a whole number exponent with no variables appearing in any denominator. Remember, a denominator means there's a fraction, so there's no x's or other letters in the bottom of the fraction. And the exponents are whole numbers. So you're never going to have 6x to the power of 1/2, and you're never going to have 6 times the square root of x. Monomial, we already covered it, is 1 term. Binomial means 2. Trinomial means 3 terms. Okay. Polynomial means many terms. There's one more thing I want to add. It's not on here. The degree. The degree of a term is the sum, so you're adding, of the exponents. So if you had 6x squared has a degree of 2. But if you had 4x y to the third, you're adding up all of the sums of the exponents. X is not raised to nothing, right? It's not raised to 0, or else it would be a 1. It's actually raised to 1. So x to the power of 1 times y to the power of 3, you are adding the exponents and we get a degree of 4. You're adding that third degree and that single degree. You get a degree of 4. That was kind of a tricky one because of that unlabeled, that understood 1. But if you had a squared b to the third, that's a degree of 5 because we added 3 and 2. Good. The degree of a term is the sum of the exponents. The degree of a polynomial is the largest degree in the polynomial. So we're talking about polynomials. This is a polynomial. This is a polynomial of degree 2. This is a polynomial of degree 2, because the highest, so we're not combining in separate terms, right? Each term is its own degree. So this has a degree 2, this has a degree understood 1, and this has a degree 0 because there's no variable. So this polynomial is a polynomial of degree 2 because the biggest exponent is a 2. I know that was a lot of information. All right, let's practice degrees. Find the degree of each term. So these are all monomials, right? These are 3 monomials. Monomial means it has 1 term. Terms are separated by the plus and the minus. So 6x squared is 1 term and negative 4x is another term because the minus sign is between them. 4x is a different term from 9 because the addition is between them. So 5 times y to the third is all one term because there's no adding or subtracting between the 5 and the y. Good? So just look at the exponent. Add the, does that make sense? Add the exponents? So this is only y to the third. So the exponent is 3. So this is degree 3. Again, if you have no number here, it's an understood 1. So that's y to the first and x to the first. So that's a degree of 1 plus 1. So that's a degree of 2 total. Eight, if you think about it, right? If I had 3x squared minus 2x plus 1. All right, let's think about the degrees of x. Here, x is raised to the power of 2. Here, it's not 0, right? X to the power of 1 is the same as x, so this is power of 1. One has no x's, but remember, anything raised to the power of 0 is 1. So 1 times x raised to the 0 power is just 1, because it's 1 times 1. So if it was back on the other example, we had 9. 9 is the same as 9 times x to the 0 power, right? Because 9 times x to the 0 power is just 9 times 1, and that's still 9. So you can always think of your constant as being multiplied by a variable to the power of 0. 8 times x to the 0 power, so that means it's a degree of 0. Or you can just remember that the constants have a degree of 0. So that's x squared. The x is being raised to a power of 2. X is being raised to the power of 1. When you just have a constant, it is power of 0. Or to the 0 power. Example 2 asks us to determine the degree of each polynomial and indicate whether the polynomial is a monomial, binomial, or trinomial. Remember, monomial means 1. Binomial means 2. Can't see that at all. And tri means 3, like triangle or tricycle. Good. All right. Notice that in this case, you will always see if a polynomial is in standard form, you're always going to see that the biggest exponent is on the left. We start with the greatest exponent and then we go to the constant. Okay, so 4x to the 5th plus 7x cubed minus 1. What is the degree of the polynomial? Remember, the degree of the polynomial means the biggest, the degree of the greatest. How do we say it? It's like the term with the degree of each polynomial is equal to the term with the greatest degree. The degree of each polynomial is equal to the degree of the greatest term. Yeah, degree. So you're looking at each term individually. This has a degree of 5. This has a degree of 3. This has a degree of 0, right? This is all one term because there is no addition or subtraction separating the x, the y, the z, or the -2. This has 2 terms, right? So this has 1 plus 2 plus 1. So that's the degree of this term alone is a degree of 4. right? So just the negative 2xy squared z has a degree of 4. The 4x to the 5th has a degree of 5. The 7x to the 3rd has a degree of 3. The negative 1 has a degree of 0. Y to the 3rd has a degree of 3. And 6y has a degree of 1. Now, those are the degrees of the terms. Take your biggest degree of the term. So this is a degree 5 polynomial. This is a degree 4 polynomial. We didn't have any to choose from. There was only one term, right? We have a 3 and a 1, so this is a degree 3 polynomial. Note that I'm not adding. I'm not adding 5 and 3 and 0 and saying this is a degree 8. I'm saying the biggest one is 5, so it's a degree 5. The biggest one is 4, so it's degree 4. The biggest one is 3, so it's a degree 3. The second part is it a monomial, a binomial, or a trinomial? So here we have 1, 2, 3 terms. So you can say it's a degree 5 polynomial or trinomial. Those words are interchangeable. You can say it is a polynomial or it is a trinomial. This is just more specific, right? You can say this is a shape, or you could say this is a square, right? Neither is wrong. One is just more specific. So square would be like trinomial, shape would be like polynomial. They're both true. One is more specific. This is a degree 4 polynomial. There's only one term because there's no plus or minus behind the negative 2. So we're going to call that a monomial. And then here we have 2 terms, so that's a binomial. You can say it's a degree 5 trinomial or a trinomial with a degree of 5. Over either of those is fine. Okay. Example 3 asks us to find the degree of this polynomial. I think I said on the last slide, but it's important to put them in order from the greatest degree down to the constant, because the constant's always degree of 0. So standard form means the degrees in descending order. So step 1 is put the degrees in descending order. You know what?
Wait, I'm sorry. Can you go back to that last page? Because I missed the last bit of notes on that.
Yes. I'm going to change that word too. I'm going to say put terms in descending order. I keep changing those two around. All right. So this guy is a trinomial because there are 3. Trinomial of degree 5 because that term has an exponent to the power of 5. This is a monomial because there are no addition or subtraction signs between any of the variables. So there's no second term. There's only one term, even if it's really long term. And then this is and it's raised to a degree 4 because, always worth re-emphasizing, because we said x is raised to the first power, y is raised to the second power, and z is raised to the first power. So that's all of my degrees together are 1 and 2 and 1. So we get the number 4.
Okay, so on the top one, it's 5 because that's the greatest one.
Yes.
So, and it's not going to be 2 on the second one because there's understood ones on the other 2 variables.
Mm-hmm.
Okay.
There you go. Yes, if you don't have any number here, but you can still see the letter, it's being raised to the first power. And so for c, y to the 3rd, and 6y, this is a degree 1, this is a degree 3, so you're taking the biggest one. And so you're saying this is a binomial because there are 2. Binomial, you could say of the 3rd degree, a 3rd degree binomial. Binomial up to with a degree of 3.
Thank you.
No problem. All right. put the degrees of the terms in descending order, or just put the terms in descending order. That doesn't mean you're looking at the 7, the 6, the 2, and the 4. You're looking at the exponents, okay? So here we have x squared, we have y to the first, x squared, y to the first, z to the first. No degree at all, degree 0, and then y to the third. So the biggest degree of each of these terms is actually, it's kind of tied, but I would start with the negative 4y to the third, because that is the only one where a variable is raised to the third power. Okay, so that one's going first because that's the only one where one variable is being raised to a third power. Then you go on to 7x squared y to the first and negative 6x squared y z. I'm going to go x squared y z. Sorry, we should have counted these. So this is a third. This is a fourth. And this is a third. Good. So actually, I'm wrong. Let's lead with that one and then move this one. So that has a fourth degree. That's a third degree. Then I'm going to go on to 7x squared y. It's going to be added because there's no minus sign in front of the 7. So we went from the greatest term, and then between the 4y cubed and the 7x squared y, I chose the y cubed because it is a single letter has a higher power than the 2 letters, even though they're both to the third degree. And then finally, we just have our plus 2. So what is the degree of this polynomial? You should always be, if it's in standard form, looking at the first term will tell you your degree, and that's a degree of 4 because x squared is 2, y is 1, z is 1. So that's a 2 plus 1 plus 1. That's a 4th degree. You'd say 4th degree or polynomial with a degree of 4. All right, shifting gears. Here we have 3x squared minus 2x minus 5, and they want you to find p. This is called p of x. They want you to find p of 1. What you need to do here is put in 1 anywhere you see an x. That's all you're doing. So if p of x is 3x squared minus 2x minus 5, p of 1 is 3. Instead of that x, you're going to put in a 1. Instead of that x, you're going to put in a 1. Everything else stays the same. So where you had an x, put a 1. 1 squared is just 1, so that would be rewritten as 3 times 1 minus 2 times 1 is just 2 minus 5. 3 times 1 is just 3 minus 2 minus 5. When you're subtracting, you can just go in order. 3 minus 2 gives me 1. 1 minus 5 is a negative 4. So p of 1 equals negative 4. Same equation. What is p of negative 2? Instead of x, I'm putting in a negative 2 now. Negative 2 times 2 is a positive 4. Negative times a negative becomes a positive. Negative 2 times negative 2, right? This was negative 2 times a positive 1, it became a negative 2. If it's easier for you to look at it as just bring down the minus and multiply positive 2 times positive 1, keep the minus and it's a positive 2, that's not going to get you a wrong answer. It's a different way to do it. Good. But I like to just look at this as a sign. So this is a negative sign for that initial 2. That negative 2 times that negative 2 is going to become a positive 4, because a negative times a negative, just like it was here, becomes a positive. And then bring down that 5. It's a negative 5. 3 times 4 is 12, I think. Plus 4 minus 5. Again, just go one step at a time or put it all into your calculator. 12 plus 4 is 16. Minus 5. 16 minus 5 is 11. So P of negative 2 is 11. You can check your answer. Trying to decide. Yeah.
This meeting is being recorded.
Sorry. I paused the recordings because I don't want to zoom out and accidentally get all of your faces or anything. All right, next. Combining like terms.
Look, I need it.
Sorry. All right. Combining like terms is the same as simplifying. All right. Those mean the same thing. Like terms are terms that contain exactly the same variables raised to exactly the same powers. Okay. So if we had 5x squared and 3x squared, obviously that can just become 8x squared, right? If I had 5x squared plus 3x squared y, I cannot simplify that. Okay, they have to have the same letters raised to the same powers. 5x squared and 3x are not going to combine. 5x squared and 3x squared y are not going to combine. All right, so again, combining like terms is the same as simplifying. You're not going to find an answer, you're just making it simpler. So negative 4y and 2y, they have this exactly the same variable of y raised to the power of 1. Negative 4 and 2 is the same as 2 minus 4, right? And so, or 4 minus 2, which is 2, but the 4 is a negative, so the subtraction, the product of subtraction gets the sign of the bigger number. Negative 4y plus 2y gives me a negative 2y. Good. Here, z and 5z cubed. If this was z cubed but plus 5z cubed, that would be 6z cubed. If this was z plus 5z, that would be 6z. As it stands, you cannot combine them. You can put them in a better order. You can say 5z cubed plus z. But it doesn't matter. That's just standard form. But you cannot simplify this at all.
So in our homework, if there was a question like that, would it be undefined?
This one?
Mm-hmm.
They just want you to type in what they already have. They're just tricking you.
Oh, okay.
Yeah. Good question. 5x cubed minus x cubed. Think about what this minus means. If you just have an x cubed, that's the same as saying you have a 1x cubed, right? So we're actually saying 15 minus 1. Good. All right, here you have two different sets of like terms. You have a positive 7a cubed. Very important to take the term in front of it. So positive 7a cubed and negative 3a cubed are like terms. 7a cubed minus 3a. Yeah, I'm saying cubed, but it's actually squared. Minus 3a squared is 7 minus 3. You're not doing anything to the a squared. You're just saying 7 minus 3 is 4. And then keeping the variable behind it. And then you have, remember, very important to remember, it's a negative 5 and a negative 7. Negative 5 and negative 7, or just negative 5 minus 7, if that's easier for you. You're combining two negatives. So 7 plus 5 is 12, right? But they're both negative, so it's a negative 12. So you need to put those two together. And you're going to say 4 a squared minus 12. Notice how I put the variable with the highest degree in front, and I put the constant at the end. This is going to come into practice when you are adding polynomials or subtracting polynomials. So when you're adding, you're just combining all like terms. You might see parentheses. Parentheses don't matter when you're adding. Parentheses matter when you are subtracting, because you need to distribute the minus sign. Okay, so you're going to take that minus, apply the minus to the 3, the -2, and the +3. Oh, you're going to apply that subtraction sign to the 3 and the -12. But when you're adding, it doesn't matter, right? Because a positive, you can think of it as a +1, right? If you had to distribute it. And you can think of your minus sign as a -1. So -1 times a +3 makes it a -3. But here, +1 multiplied by any of this isn't going to change any of those terms. So that's exactly the same as 3x minus 8 plus 4x squared minus 3x plus 3. Those parentheses did not signal anything. You didn't need to do anything special because of those parentheses. You can erase them if you want. So now you're just going to go through and look at maybe starting with the highest degree. We have a positive 4x squared, and it can't be combined with anything. Then the next highest term is just x to the first. So we have 3x to the first and -3x to the first. So plus 3x minus 3x. And then you have -8 here and plus 3. So you can put them all in order, make sure you used all of them. This one had 1, 2, 3, 4, 5 terms. This still has 5 terms. Good. And now you just simplify. So 4x squared wasn't combined with anything. Positive 3x minus a 3x, that just disappears. Those cancel each other out. -8 plus 3. You can subtract. 8 minus 3 is a 5. But the 8 had a negative, so -8 plus 3 is a -5. You're just subtracting, and then you're giving your answer the sign of the bigger term. Good. All right, same thing here, where we have an and between them, but it's addition, so it doesn't matter. So we have 8y to the third minus 4y squared plus 5 plus 5y squared and 1. I know it's a plus because it says add right here. If this said subtract and this was an and, you would then have to subtract, put a minus sign there and a parentheses there, but I wouldn't worry about that. All right, what is our highest degree? It's the 8y to the third. Then we have -4y squared, and we have a positive 5y squared. And then we have 5 and 1. Good. So that just becomes 8y cubed minus 4y squared plus 5y squared plus 5 plus 1. And you can simplify that to 8y cubed was not combined with anything. -4y plus 5y squared. It's just saying 5 minus 4, which is just 1, right? So I can say plus y cubed, because y cubed is the same as 1y cubed. 5 minus 4 is 1. And then 5 plus 1 is 6. Here we have x squared y plus xy minus y plus 10y squared y minus 2y plus xy. So x squared y and positive 10x squared y. Then we have positive xy plus xy minus y minus 2y. Again, you can count the terms 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. And then you just combine x squared y plus 10x squared y. That's like a 1. 1 plus 10 is 11. Here we have xy plus xy. So that's a 2. Because those were each 1. And then negative y minus 2y. The negative y is a negative 1. A negative 1 and a negative 2 combined to get a negative 3. Sorry, I said we'd be done 10 minutes early and we are not. But okay, 5 more examples. All right, to subtract a polynomial, add its opposite or change the sign of the polynomial being subtracted and follow the rules of addition. So you're taking that to subtract a polynomial, add its opposite. That's not really helpful. Change the sign of the polynomial being subtracted and follow the rules of addition. That doesn't mean just put a negative here. It means change the sign of each term. So that becomes 7x minus 8. Think of this minus sign as a negative 1. So we have a negative 1 times 3x, and we have negative 1 times negative 12. Good. Negative 1 times 3x becomes a negative 3x. Negative 1 times a negative 12 becomes plus 12. So I distributed a negative 1 to the 3x and the negative 12. I got 7x minus 8 minus 3x plus 12. Now you can combine 7x minus 3x. And here you can combine negative 8 and positive 12. Good. 7 minus 3 is 4. And then negative 8 and 12, again, you're subtracting. 12 minus 8 is just 4. The 12 was positive, so the 4 is positive. Good. All right, again, very important, distribute that negative 1. So it's a negative 1 times a positive 3x cubed. Negative 1 times negative 2x squared. Negative 1 times a positive 3. So that becomes 2x cubed plus 8x squared minus 7x. Negative 1 times a positive 3x squared is a negative 3x, cubed. Negative 1 times the negative 2 becomes a positive 2x squared. And then negative 1 times a positive 3 becomes a negative 3. You don't have to do it this way if you know that you just put a minus in front of this one, a minus in front of this one, and a minus in front of this one. That's fine too. We'll give you the right answer. Whatever you feel comfortable with and works for you is totally fine. Now we're just combining like terms. 2x cubed minus 3x cubed. And then we have 8x squared and 2x squared. And then we have negative 7x. Does not get combined with anything. And then we end with a negative 3. Good. 2x cubed minus 3x cubed. 3 minus 2 is a 1, right? But the 3 is bigger than the 2, so it's a negative 1x cubed. 8 and 2 is 10. Minus 7x minus 3. Here we have 4 minus the quantity, negative y minus 4. So that means we're multiplying negative 1 times negative y and negative 1 times negative 4. Good. So that becomes 4, -1 times a -y becomes plus y. -1 times a -4 becomes plus 4. So those were both negative, but they were both subtracted, so they became positive. The only terms you can combine are the 4s, so you just have y plus 4, because 4 is the constant, 8. The constant should always go at the end. Here you're subtracting only these two, and then you're adding these 3. So that means I'm going to multiply -1 times a positive a squared and -1 times -3. Everything else will stay the same. So if I rewrote that, it would be -a squared plus 1. -1 times a positive a is a -a squared. -1 times a -3 is a plus 3. Plus 5a squared minus 6a plus 7. Sorry. Now you're just combining terms. So -a squared, -a squared, and positive 5a squared are all combined together. 5 minus 1 is 4, minus another one is 3. So I'm going to call this 3a squared. Good. -6a. It's the only one, so we're just going to say -6a. And then plus 3 plus 7. It's just a positive 10. And again, you can count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Make sure you, oops. Oh, I forgot that one, sorry. 11. So it's 3a cubed minus 6a plus 11, because I forgot that guy. All right, this one is just addition, so you do not even need the parentheses. You can write this all again without the parentheses. It is just 3x cubed minus 7xy plus 8y cubed minus 2x squared plus 9xy minus y squared. What is your biggest term here? We have a 3x squared, 7xy, 8y squared, -2x squared, xy, and a -y squared. Traditionally, you go alphabetical, so I would say x squared goes in front of y squared. So we have 3x squared minus 2x squared. Plus 8y squared minus y squared. And then these. -7xy plus 9xy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You have the correct number of terms. Now you can just combine them. 3 minus 2 is just 1. 8 minus 1 is just 7. -7 plus 9 is the same as 9 minus 7, so that is 2.